Hey guys, what's up? Welcome back to my YouTube channel. In this video, I'm going to be continuing my LeetCode series, and today's problem is called Count and Say. It's a medium problem, so it's not really that difficult, but it's really interesting, and I wanted to share it with you guys. Before I get into the video, I just want to thank you guys for 70 subscribers, as that's a huge milestone, and I appreciate all the support you guys have been giving me, and I plan to make a lot of new videos for you guys. Now this problem, it says the count and say sequence is a sequence of digit strings defined by the recursive formula. That's kind of technical, so let me just simplify it a little bit. What they're asking is that basically they're going to be giving us a string, and we have to divide it into several substrings, where each substring is going to have a certain number of digits that are all the same. So for example, in this test case, 33222251 over here, we have 2 3s, 3 2s, 1 5, and 1 1. So we have 4 substrings here. The first substring is 3 3. The second substring is 2 2 2. The third substring is 5, and the fourth substring is 1. Okay, and so we're gonna divide it into 4 substrings, where each substring is gonna have a certain number of identical digits. Now, to implement this, I'm going to use like a recursive technique, where I'm going to kind of keep on calling on the function, and eventually it's just going to divide this string into many substrings. If you don't know what recursion is, a recursive function is it's basically just like a function which you call the function when you're defining it. So when we're defining the function over here, we're going to call it inside its definition. So we're gonna call the count and say function while we're defining it. Now that might seem really confusing, because won't that like produce an infinite loop? You might think that it's gonna keep on going forever and ever, which is why we need kind of like a base case to kind of stop that from happening. We'll talk more about that later, but I kind of just want to mention that right now we're gonna just define a couple of variables. We're gonna start with digit string, which is gonna be the string that we're gonna be iterating through. Now, here in this another test case over here, it's n equals to 4. So that means we're going to have to provide the 4th term in this count and say sequence. So here in the explanation, it says the first string is going to be the first term is going to be 1. Now here we have 1 1, and so to explain that, I'm just going to comment. We have 1 1 over here, right? 1 1. That means we just have a singular digit, which is 1. Now if we take 1 1, we can get 11. Now in 11 we have 2 1s to get, and from 2 1s we can get 21. In 21 we have 1 2 and 1 1. So here we have 1 2 and 1 1, from which we can get 1211. And so this sequence keeps on going forever and ever, and so we have to provide a certain term for the sequence. So now in this code, what I'm trying to do is, first of all, I'm gonna call this recursive function. So if we have the function count and say 4, it's gonna do where n is 4. So n minus 1 is gonna be 3. So when we call count and say 4, we're gonna be calling count and say 3, and we're gonna be calling count and say 2, and count and say 1, and finally in count and say 1, we're gonna get the function is going to recognize that if the input is 1, then we're going to return 1, because that's going to be the base case to stop it from going into an infinite loop. Now once we have 1 as the value that we're returning, we're going to go all the way back, and now the real logic of this function is found in the for loop here. In the for loop we have for I in range, and in the length of digit string minus 1. The reason I'm doing the length of the digit string minus 1 is because, like, for example, digit string here is going to be this number. Digit string just represents like the input that we're receiving. It's going to be kind of like the number, the main string, which we have to split into several substrings. So the reason I'm doing minus 1 is because like for example, this string has 7 digits, but I'm only gonna call this for loop 6 times, not 7 times, because as you can see, if we fast forward a little bit in the code, we're gonna be indexing the next digit in the string, and we can't index the next string if we're on the last string. If that makes sense, it's like if we're on the last string in this digit string, we can't. There's no digit for us to index, which is after this. Okay, right? So instead of running it 7 times, we're gonna run it 6 times, so that when we're on the second to last digit, we can index the next digit, and then that's just gonna prevent the the list from erroring, because we're gonna get an error if we kind of, how do I say this? We're gonna get an error if we try to index a value that's not there. Okay, that's just how we're gonna. That's just the simplest way to put it. That's why it's digit string -1. Now in this for loop, it's pretty simple. We just have to equate if 3 is equal to the next digit. So for example here, the first digit is going to be 3, and we have to basically validate that the next digit is also equal to 3. To do that, we're going to see if digit string I, which here that's 3, if that's equal to digit string I plus 1, which is going to be 3 as well. So here we can kind of validate that 3 is in fact equal to 3, which is why we know that this is actually a substring. We have 2 3s over here. So we're just gonna kind of add 1 to the digit count. Another example is, like, for example, if we have 3 2s over here. So the first digit is 2. Now we're gonna see if 2 is equal to the next digit, which is also 2. And then we're gonna see if that equals to the next digit, which is also 2. So we have a substring which it comprises of 3 2s. Okay, so that way we can, the digit count is just kind of like the variable that represents how many digits are the same in that substring. So we have 3 2s over here. So digit count is gonna represent 3. Now, if like for example, if we're on the second 3 here, and we have to see if the next digit is equal to 3. In this case, it's not, because 2 is not equal to 3. So here we're gonna end the substring. We're gonna have just 2 3s, and so we're gonna append that to the answer. New string is like a variable that we defined. It's basically like the new string that we're getting out of this whole program. So like out of this whole code, and the new string is just gonna be the answer. Which in this example, the answer to 3322251 is gonna be 2 3 3 2 1 5 1 1, because we have 2 3s, 3 2s, 1 5, and we have 1 1. Okay, so that's gonna be the answer. Now this is just kind of like the logic where we can kind of identify substrings and find the values of them. Now here we're just what I'm trying to do here is, let's say the substring never ends, because what if the substring kind of makes up the entire string? Maybe the string is 1 1 1 1. Here we have 4 1s, and the substring is never gonna end because we only have 1 digit, and that's gonna the whole string is just one big substring. So here we're just gonna copy paste the code, where the first term is gonna be how many digits there are. So here we have 4 1s, right? So this is gonna be equal to 4 because we have 4 1s. And the second term is gonna be 1 because that's how many, that's the actual digit itself. This is just how many digits there are, and this is gonna be the digit itself. So this is gonna be 4 in this example, it's gonna be 4, and this is gonna be 1. So we're gonna have 41. Because that's going to be 4 1s, which is 41, and we're going to append that to the answer we have over here, new string. So this, the main logic here, what it does is it kind of just, it splits the main string into a bunch of different substrings, and that way, if we have 3 3 2 2 2 5 1, here we have 2 3s, 3 2s, 1 5, and 1 1, which is why our answer is going to be 2 3 3 2 1 5 and 1 1. Now, if this whole recursion thing still doesn't make sense, I have kind of like a new way to explain it. Here, if we call the function count and say 4, then again we're gonna run the function while we're defining the function, which is why it's called a recursive function. So count and say 4 is actually going to run count and say 3, which is going to run count and say 2, which is going to run count and say 1. And so this way, if we take this example, n equals to 4. If we call count and say equals to 4, then what we're really trying to do is we're going to keep building on top of these values. And so it's going to go from 1 to 11 to 21 to 1211. This way, when we reach the base case over here, we can go all the way back, and eventually we're going to reach the answer here, which is going to be, for example, here it's going to be 2, 3, 3, 2, 1, 5, and 1, 1. So that's basically the code. It's kind of confusing because it may be confusing because of the idea of recursive functions, but I hope I explained it well enough so that you can understand it. So that was the video. Don't forget to subscribe to my channel, smash that thumbs up button, and share the video with all of your friends. And so that's it for this one.